Hello everyone, this is Omkar Galvi from CVP's Academy, and this video is going to be a part of the CET crash course videos that are being uploaded on the YouTube channel. And the chapter that I'm going to do today is Introduction to Polymer Chemistry. Okay, so this is a very simple chapter actually, and very easy questions come in the exam. परीक्षेत खूप सोपे प्रश्न येतात या chapter मधून. So what we are going to do in this video is that we are going to have an overview of the chapter, पूर्ण रिव्हिजन करून घेऊ आणि मग त्याच्यानंतर या चॅप्टर वर जे क्वेश्चन्स आलेले आहेत किंवा ज्या क्वेश्चन येऊ शकतात ते आपण सॉल्व्ह करू. So first we would have an overview of the entire chapter and then after that we would solve a few questions on this. All right. So let us move on to the quick overview of this chapter. So this chapter is all about polymer chemistry. Polymer chemistry emerged as a new science actually much later after polymers started playing an important role in our lives. One of the most famous polymer that we are aware of is polyethylene, which is also called as polythene. Okay, and this polymer has now become an integral part of our lives. आणखीन एक पॉलिमर आहे पीव्हीसी म्हणून, तो पण आपण खूप भरपूर गोष्टींसाठी वापरतो. All right, so first we will discuss about the classification of polymers on the basis of their origin, and similarly there are various different kinds of classifications along with the various kinds of polymers that you have studied in this chapter. And once we have finished revision of all this, we can move on to the questions. So let us quickly come to classification on the basis of source. Third, on the basis of source, यानी कि polymers कुठून derive झालेले आहेत. On the basis of that, we can derive polymers as natural, synthetic, and semi-synthetic polymers. Okay. Now it is quite obvious. Natural polymers are derived from natural sources such as plants and animal sources. The best example for that is cotton, linen, and silk. Okay. Cotton and linen, cotton comes from cotton plant as well as silk comes from silkworms. So these are natural sources and hence the polymers we derive from that are called as natural polymers. Similarly, when we move on to synthetic polymers, it is quite obvious from that. What does the word synthetic mean? Synthetic means something that is man-made or something that has been created artificially. Okay, so artificially prepared by polymerization of one monomer or by copolymerization of two or more monomers. Okay, synthetically in the laboratory are synthetic polymers. One of the best examples for that is nylon or Teflon. Okay, nylon is very commonly used in ropes that are used for various sports activities such as rappelling and all that. And along with that, we also use nylon for a variety of other purposes also. Okay, Teflon is present in the non-stick coating of aluminum utensils nowadays, non-stick cookware that you call it. Similarly, semi-synthetic polymers or regenerated fibers. What are these semi-synthetic fibers or regenerated fibers? That are derived from natural sources only, but they have undergone some chemical modification inside them. So if there is some form of chemical modification inside them, then they are derived from nature ultimately, but they have some laboratory treatment. So such kind of polymers are called as semi-synthetic or regenerated fibers. The best example for that is acetate rayon, viscose rayon, or cellulose nitrate. Cellulose nitrate is one of the most common examples. Now these synthetic polymers that you see, they are further divided into three more categories if you see carefully. The first one of them is fibers, okay, synthetic fibers or those which are used to make garments or the clothes which we wear, okay. The best example for that is nylon. Even terylene or terrycot is one of the most common examples. Terrycot is a mixture of terylene and cotton, okay. So those synthetic fibers come under this category. Similarly, synthetic rubbers are a synthetic derivative for rubber, okay. Something which you use for applications where rubber is found. For example, Buna S. Okay, Buna S is one of those synthetic rubbers that you use for, you know, you could say you can use it for making tires or any other application where rubber could be used. Say you can make some industrial seals also with that. So they are used for these particular purposes. Similarly, if you consider plastics now, plastics form an essential part of our lives. There are various kinds of things that you can make using plastic. Bakelite is used for making switches. Okay, the electric switches that you see around you are made up of bakelite. Similarly, melamine is another polymer that is used for making dining ware. Okay, which is used for making cookware. You can say, well, not cookware precisely. Non-stick cookware made Teflon is used. Melamine can be used for making dishes and cups. Okay. So this is all about classification on the basis of source. The next is classification on the basis of structure. So on the basis of structure, you can again classify polymers into three categories: linear or straight chain, branch chain, or network or cross-linked polymers. Okay. Now in linear chain, it is quite obvious that all the monomers, what are monomers? Those small molecules which ultimately make up polymers. Polymers are nothing but macromolecules. How are they made? They are made up of small monomers that are linked together by chemical bonds. So in these linear or straight chain polymers, these monomer molecules are linked together in linear arrangement or a straight chain arrangement. And they are obtained from bifunctional monomers or alkenes. All right. So from bifunctional monomers or alkenes, these linear or straight chain polymers are derived. One of the best examples for that is PVC and high density polyethylene. So HDPE is a linear or straight chain polymer. All the monomers are arranged in a straight chain for them. Coming to branch chain now. For branch chain, these polymers are actually branched, or long chains have some branchings in them. Okay. So if they have certain branchings in them, okay, they will have molecules that are poking out of the polymers like this. Okay. One of the best examples for that is LDPE or polypropylene. Okay. Now, if the monomers contain side chains, then these polymers would also have side chains or side groups attached to them. Okay. Coming to network or cross-linked polymers, in which linear chain polymers or straight chain polymers will have cross-links. So if these are two linear chain polymers, then they would have links between them like this. Such kind of polymers are called as network or cross-linked polymer. One of the best examples for that is melamine or bakelite. So all this is related to classification on the basis of structure. Now moving to classification on the basis of polymerization process. So depending on the process by means of which their polymerization is carried out, you can again classify them into three categories on the basis of chain growth, on the basis of condensation or step growth polymers, or ring opening polymers in which the ring opens. The first thing that we are going to discuss is addition or chain growth polymers, okay, in which there is simple addition reaction that would take place between monomers. The best example is Teflon. So what is Teflon? Teflon is formed by the monomers of tetrafluoroethylene, okay. So simply the bond shifts here and the chain goes on lengthening. So simple addition processes have happened here, and if the polymers are formed by simple addition or chain growth, they are called as addition or chain growth polymers. The best example for that is PAN or Teflon. Polyacrylonitrile is the full form of this. What is the full form of PAN? Polyacrylonitrile. Okay, this is another addition or chain growth polymer. Coming to what is condensation or step growth polymers. What is the meaning of condensation or step growth polymers? They are formed by condensation of two or more than two bifunctional monomers. So what is a condensation reaction? A condensation reaction is a simple reaction in which you have a small molecule which is eliminated along with bond formation between two species. So a reaction that is accompanied by elimination of small molecules like water or ethanol, such kind of reactions are condensation reactions. Polymers that are formed by such kind of condensation reactions are called as condensation or step growth polymers. Is that right? So that is what has been defined here. Okay. So formed by condensation of two or more than two bifunctional monomers with the elimination of small molecules like water, methanol, HCl, ammonia are called as condensation or step growth polymers. The example for that is terylene, nylon 6, etc. Now the last category under this type is ring opening polymers. What are these ring opening polymers? They are formed by addition of monomers to a growing chain molecules without elimination of strong molecules. So basically what is happening, the ring opens and no small molecule is eliminated. The best example for that is epsilon caprolactam. Okay, epsilon caprolactam is one of those polymers that is formed by ring opening. Okay, the ring opens in that. Okay, moving on. Next, on the basis of intermolecular forces of attraction, they can be classified into elastomers, thermoplastic polymers, fibers, or thermosetting polymers. Let us discuss all of them one by one. Okay, so coming to elastomers here. So they are elastic in character. We are aware of this word elastic. Okay, now why are they elastic? Okay, because of van der Waals forces and crosslinks. So because they have crosslinks between them and the van der Waals forces that are operating, they are going to be elastic in character. Okay, similar to rubber. Rubber is elastic. Okay, why does a ball, okay, you can say when you hit a ball with a bat during a cricket match, why does the ball get flung away? Okay, the ball gets flung away due to the elastic nature of rubber, right? If the ball wouldn't have been elastic, then the ball wouldn't have been flung, we wouldn't have had a six, right? So similar to that, we can assume that these elastomers are elastic in character. Vulcanized rubber, Buna S, neoprene are all examples of this. Coming to fibers now, they have very strong intermolecular forces such as hydrogen bonding or dipole-dipole interaction. Now, all of us are aware that hydrogen bonding is a very strong kind of force. Okay. Also, dipole-dipole interactions that exist between molecules are also very strong. So, because of these strong interactions, these have very strong intermolecular forces and their tensile strength is very high. They cannot be broken easily. If our clothes start tearing, then that wouldn't be a desired material for us, right? So that is why terylene and nylon 6,6 are very high. We use nylon rope for rappelling, rock climbing, and all such sports activities. What if the rope snaps or breaks? That will be a very dangerous situation for a person to be in, right? But dangerous situation खड़ी हो जाएगी फिर उस केस में. So इसलिए they have to have a very high tensile strength. Next, thermoplastic polymers, they are softened easily on heating. This is the only important thing which you should remember. This is where questions might come in the competitive exam. They may ask you, okay, give or mark the correct statement for thermoplastic polymers, or they might tell you mark the incorrect statement for thermoplastic polymers. So in that case, you should know the properties of these polymers very well. Okay, so they are softened easily on repeated heating and hardened when cooled with little change in their properties. The best example for that is polystyrene or PVC. Finally, coming to thermosetting polymers, they are infusible solids with highly cross-linked or heavily branched structure due to strong covalent bonds and undergo permanent change on heating. So once you heat this, they are going to completely melt. The best example for that is bakelite. You know, to give you an example of thermosetting polymers, if there is some electric failure in your house, you see that the switchboard melts. If the switchboard melts, you need to get a new switch. All right. Why is that necessary? Because once bakelite melts, you cannot remold it again. Does the electrician come and remold it? No, right? He installs a new switch. That is because bakelite cannot be restored into its original form once it has melted. So such kind of polymers are called as thermosetting polymers. Okay. So now let us move on to the next slide. So on the basis of different monomers, we have just two, homopolymers and copolymers. Okay, homopolymers and copolymers. What are homopolymers? Those which contain only one type of repeating unit, for example, nylon 6,6, PAN, polyacrylonitrile, and those which contain two or more types of repeating units, such as Buna S and Buna N. So this is quite easy for us to understand. Now, on the basis of biodegradability, this is quite interesting because we have biodegradable polymers and non-biodegradable polymers. One of the biggest drawbacks of polymer industry is that its products are not biodegradable. But what if we contain something which is biodegradable by nature, such as PHBV, that can be degraded by microbes, okay, or nylon 2, nylon 6. So these will go under the category of biodegradable polymers, and non-biodegradable polymers will be what? Those which are not affected by microbes. For example, nylon 6 and terylene. That is the biggest drawback of polymer industry, right? Polythene bags were banned a few days back. Why were they banned? Because they are not biodegradable. Okay. So on the basis of biodegradability also you can classify them. Now, what you need to know about various polymers is that you just need to know their monomers, because that is what will be asked in the exam, and you should know how the polymer actually looks like. I think this knowledge should be enough for you to cover your competitive exams. Okay. So what you should know is the monomer which has been used to form that particular polymer, as well as the final structure of the polymer. Okay. So the very first polymer that we are discussing here is rubber. So we have natural rubber. The monomer for natural rubber is isoprene, and the polymer that is formed is polyisoprene. So what happens in this is that isoprene polymerizes and forms natural rubber. Okay, so this is the structure for natural rubber. Now, if you look at synthetic rubber, we have Buna S, neoprene, and Buna N. Okay. Now, Buna S is for styrene. If you see carefully, S stands for the S of styrene. Okay. So, the monomers for Buna S will be styrene along with butadiene. And here, if you see carefully, this molecule is styrene, and styrene has polymerized with butadiene and has given you Buna S. Similarly, for neoprene, we have chloroprene. There is a chloro group at position 2, and this polymerizes to give you neoprene. And Buna N is between acrylonitrile and butadiene. So acrylonitrile along with butadiene is going to form this polymer, Buna N. Now, some more important polymers that must be discussed are polyethylene. Okay, polyethylene is of two types: LDP, which is branched, and HDP, which is linear. So the low density polyethylene is a branched polymer, whereas the high density one is a linear polymer. You should remember this because this has come in the competitive exams many times. Now, polyamides maybe have nylon. The best example for nylon is nylon 66 itself. This is also very important because the monomers are quite frequently asked for your exams. So the monomer for that is adipic acid and hexamethylene. So there has been a mistake here. This is hexamethylene diamine. Okay, so you have adipic acid here and hexamethylene diamine here. They polymerize and give you nylon 6. Similarly, if you consider nylon 6, the monomer is epsilon caprolactam. What is epsilon caprolactam? It looks like this. It is a cyclic ester actually. Lactams are cyclic ester. So if you have a system which looks like this, okay, this is a cyclic ester, and such compounds are called as lactams. Okay, or more precisely, cyclic esters are called as lactones, and lactams are cyclic amides. Okay, so if you have an NH group here along with C double bond, lactone is a cyclic ester. I mentioned that wrongly earlier. Lactone is a cyclic ester and lactam is cyclic amide. Okay. So nylon 66 में the monomer is epsilon caprolactam. So that is actually a cyclic amide which looks like this. And then we have a ring sort of thing. So we have these 5 carbons over here. Okay. These 5 carbons are present in the ring. They form a chain like this. Okay. This is epsilon caprolactam. Moving on, some polyesters. One of the best example is terylene, which is also called as dacron. So they might confuse you by asking write down the monomers for dacron. So you should not get confused there. And dacron is nothing but terylene, and its monomers are ethylene glycol, okay, and terephthalic acid. So this is ethylene glycol, as we are all aware. And what is terephthalic acid? Terephthalic acid is benzene ring along with two COOH groups at terminal position. Okay, so this is terephthalic acid. Moving on. Some more important polymers are discussed here. So we have Teflon, as I already mentioned. The monomer for that is tetrafluoroethylene. Okay, this is how the polymer looks like. Acrylonitrile, say we get polyacrylonitrile. This is one monomer of acrylonitrile which polymerizes and gives you PAN, which is polyacrylonitrile. And the last one is melamine formaldehyde polymer. Okay. So for melamine and formaldehyde polymer, this is the structure. Okay, melamine is used for making dishes. Then this is a very important polymer, which is bakelite, where its polymers are phenol and formaldehyde. As you see, it has a cross-linked structure somewhat like this. Okay, it is an example of a cross-linked polymer. Okay, this is bakelite, as you can see. Now, some biodegradable polymers also need to be discussed. One of the best examples for that is PHBV, polyhydroxybutyrate copolymer polyhydroxyvalerate. So, what is this? Just call it beta. So, this is not beta. The name for this is polyhydroxybutyrate copolymer polyhydroxyvalerate. Okay, this is the full form of PHBV. Okay, the monomers for that is beta hydroxybutyric acid or 3-hydroxybutanoic acid and beta hydroxyvaleric acid or 3-hydroxypentanoic acid. And this is how the structure looks like. Okay, so if you can see carefully, you have the pentanoic acid part here, whereas the butanoic acid part resides here. Okay, moving on. Nylon 2 nylon 6 is also a biodegradable polymer. Its monomers are glycine and this is epsilon amino, sorry. This is glycine and epsilon amino caproic acid. Okay. So you have glycine here and epsilon amino caproic acid lies here in this structure. Okay. And some last commercially important polymers which are important, you should know its monomers because this can come in the exam. Perplex or acrylic grass. Okay, this is perplex or acrylic grass. The monomers are methacrylate, which looks like this. Okay, it polymerizes and gives you perplex or acrylic glass. Buna N is nothing but nitrile rubber. So N stands for the nitrile group that is present. So butadiene along with acrylonitrile, you have butadiene here and acrylonitrile here. So they combine together and form this polymer which is called as Buna N. Similarly, the most commonly used everywhere in plumbing pipes to buckets to mugs, everything is made up of PVC, polyvinyl chloride. So its monomer is vinyl chloride. It undergoes polymerization and gives you PVC or polyvinyl chloride. The next is polyacrylamide. So quite obviously its monomer is acrylamide. Okay, so this is the structure of acrylamide and it polymerizes to give you polyacrylamide. If you consider urea formaldehyde resin, okay, then the monomers are urea, which you see here, and formaldehyde is nothing but the CH2 group. So formaldehyde is just giving you the CH2 group, and this NH, C double bond O NH comes from urea. Glyptal is one more polymer, but the only difference is it is very similar to Dacron if you see, terylene. But the only difference is along with ethylene glycol, now we have phthalic acid instead of terephthalic acid. So such kind of small differences you have to remember. I hope this is clear. So for phthalic acid, the only difference is the orientation of COOH group. So if you consider this as the benzene ring, for phthalic acid, two COOH groups are at ortho positions. This is phthalic acid. And similarly, for terephthalic acid, what we can do is we can consider these COOH groups to be at terminal positions. Okay. Next, if you consider polycarbonate, it consists of bisphenol. So this is bisphenol and phosgene. Phosgene is nothing but a very poisonous gas called as carbonyl chloride. Okay. If you combine that, you get polycarbonate polymer. And the last is a very famous decoration polymer, which is thermocol. We use thermocol for our school projects. Okay. And for decorations also, we use thermocol very frequently. And the only monomer for that is styrene. Styrene undergoes polymerization and gives you thermocol that we see, right? So finally, we've done with the revision of this chapter. Now let us quickly solve some questions based on these topics and which may come in your competitive exams. Okay. So if you see, the very first question is there on your screen right now, and the question says polymers are. So polymers are nothing but macromolecules that are made up of small molecules called as monomers. So in this case, the correct answer for this question would be B, macromolecules. Now, the molecular mass of polymers ranges between. So if you see in the definition of polymers, it is clearly mentioned in the textbook. Okay. And it says that polymers are macromolecules having a very high molecular mass corresponding to 10 raised to 3 to 10 raised to the 7 unified mass. Okay. So in this case, the answer is A. Okay. Moving on. Now, which is a linear polymer? So what did we study? Linear polymers have all the monomers arranged in a straight chain. LDPE is a branch chain, so this cannot be the answer. Melamine is a cross-linked polymer as well as bakelite. The only option here that we have is HDPE or high density polyethylene is the correct answer. Okay, if we go back, we can very clearly see in this. Just if you see that here in the example which I gave you. If you see this, LDPE is branched and HDPE is linear. I told you to remember that because it comes in the exam. Okay, I hope that is clear. The answer is HDPE, option A. Identify the incorrect statement. So what do we have to do is we have to identify the incorrect statement from this. Okay, let us look at the first statement. The repeating unit of an addition polymer has the same elemental composition as that of the original monomer. It is not necessary. Yes, it is true, because if the repeating unit is the same, then you get the same addition polymer, right? For example, if you consider Teflon, the elemental composition of the monomer is same as that of the total addition polymer that is formed, right? So this statement is correct. If you consider the next statement, formation of polyethylene from ethylene is an example of addition polymerization. Yes, this is also true. Addition polymerization is also known as Wheeler polymerization. Yes, true. But now look at the last statement. Free radical mechanism is the most common in condensation polymerization. Is this true? No, it is not necessary that it has to be true. Okay, it is not the most common method. So this is the incorrect statement. Read the question carefully always, because हम जैसे ही देखेंगे we may think ओ चलो correct statement बताना है, correct statement ढूंढ के टिक लगा देंगे, गया question. Okay, so that is why you must always look at what is given. Okay, moving on. Arrange the steps according to the order followed in free radical polymerization. So in free radical polymerization, we are already aware of the steps that are involved. So first, the free radicals are formed. So first we have free radical formation, wherein free radicals are generation. Then in the next step, we have chain initiation, where now the chain is initiated. Okay, then we have chain propagation, where the chain begins to lengthen. And finally, we have chain termination. Okay. So what is the order? First is free radical. Then we have chain initiation. Then we have propagation. Then we have termination. Okay. So एक ही option है जिसमें 3 पहला है, तो 1 सेकंड में हो गया. अच्छा नहीं 2 थे. So how would we classify that? Second we have chain initiation. Then we have 4. तो ये नहीं होगा. Sorry. In this case, this will not be the answer. The answer will be option P, because chain propagation happens and then you have chain termination. So option C is your correct answer. Moving on. Look at this next question now. The process of formation of macromolecules by combination of polyfunctional monomers with the elimination of small molecules, I told you, is condensation polymerization. In condensation reaction, small molecules like water, methanol, ammonia are eliminated. So similarly, in condensation polymers, condensation reactions happen. These small molecules are eliminated and you get condensation polymers. The treatment of rubber with sulfur. So you must have definitely studied the chapter before approaching this. And in that, there was a small point where in order to strengthen rubber, we carry out a treatment with sulfur, which is called as vulcanization. In that case, the answer would be A, vulcanization. Now, what is natural rubber? Natural rubber is a polymer of what? It is a polymer of 2-methyl-buta-1,3-diene, right? It's the polymer of this. Okay, so it is nothing but option B. This is how the polymers progress. This bond shifts here, this bond shifts here, and one more polymer would come this, and the chain begins to lengthen. This is natural rubber. So the answer is option B. Which of the statement is not true for LDPE? So what do you think is the correct answer? Which of the following statements is not true about LDPE? So for LDPE, if you see carefully, it is obtained by polymerization of ethylene at high pressure and high temperature in the presence of traces of O2. Yes, this is true. It is a branched homopolymer. True. It is used for the packaging and in manufacture of squeeze bottle containers. And if you see, C option is it is a good conductor of electricity. In that case, if it would have been conducting electricity, then all the plastic materials that we have around us, they would leak current. But that is not the case. Plastic does not leak current, right? Do polythene bags leak current? No. So this is the incorrect option, that it is a good conductor of electricity, which is a false statement. It is a bad conductor of electricity. Moving on, Ziegler-Natta catalyst. So it is a rhodium catalyst, which we have discussed, and this is the structure for that. So this is a straightforward question. Answer is option B. The compounds that are used in the preparation of nylon 6,6. So which compounds are used in the preparation of nylon 6,6? Hexamethylene diamine and adipic acid. Okay. So the answer is option B. What is the structure for adipic acid? COOH, CH2, 4, COOH. Okay. Plus hexamethylene diamine. There are 6 methyl groups. That's why hexamethylene diamine. Okay. These are the monomers that are used for nylon 6. Okay. The IUPAC name of adipic acid. So as I already told you, adipic acid is what? CH2, 4 times COOH. So in the nomenclature, what do? We consider the total number of carbon atoms, right? So how many carbon atoms are present in all? 1 here, 4 here, 1 here. So the total number of carbon atoms here is 6. So it is hexanoic acid, some hexanoic acid. Now, as you know, according to the rules of IUPAC nomenclature, Carbon atoms must be present at 1 and 6 positions. Okay, so the answer in that case would be hexane 1,6-dioic acid. Why is the E retained? Because there are two COOH groups. Because two COOH groups were present, the E is not dropped. It is included in the name of the alkane and you include the prefix di in front of oic acid. So the complete name in this case would be hexane 1,6-dioic acid. Which of the following is used to make non-stick cookware? I've already told you polytetrafluoroethylene, which is also called as Teflon, is used for the making of non-stick cookware. The formula for adipic acid is already discussed, COOH CH2 4 times COOH. This is already discussed. Now, which of the following represents the structure of melamine? So if you see here carefully, this was the structure of melamine. Okay, we have discussed this. So there was a triazole kind of structure here. Okay, where we had 3 nitrogen atoms and 2 we had NH2 groups, and then melamine formaldehyde polymer was formed. So D is your correct answer. Melamine looks like this. Now, which of the following is dacron? What is dacron? Dacron is nothing but pteridine. What are the polymers of pteridine? Terephthalic acid and what are the just a minute, what is the question? Here you go. So what are the monomers of pteridine? The monomers of pteridine are terephthalic acid and ethylene glycol. So this is the structure for terephthalic acid and ethylene glycol, which is CH2, CH2, OH, OH. So what you can assume here is that a water molecule is lost and the structure of the polymer would look somewhat like this. C double bond O, C double bond O here, O, CH2, CH2, O, N. Okay, so which structure looks similar to this? It is obviously this. So option P है हमारा correct answer. Okay. Buna S is also called as, now I told you S here stands for styrene, if you remember. So this is styrene. So S in Buna S stands for this styrene. So it is nothing but styrene butadiene rubber. Okay, option D is your correct answer. Now, Glyptal polymer is formed from or obtained from ethylene glycol on reaction with. I told you the only difference between Glyptal and dacron is that in dacron or pteridine we use ethylene glycol and terephthalic acid. In Glyptal we use ethylene glycol with phthalic acid. So option D is your correct answer. Which of the following monomers are used for the making of PHBV polymer? Okay, so PHBV is polyhydroxy. So this is polyhydroxy butyrate copolymer polyhydroxy valerate. Okay, so 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. The common name for pentanoic acid is valeric acid. So which is the option which is similar to that? Option A is your correct answer. Which of the following is not a homopolymer? Okay. Now, what is a homopolymer? That are formed of similar types of atoms. So polyvinyl chloride may we have vinyl chloride. Okay, polyethylene may have we have polyethylene. Ethylene molecules are undergoing polymerization. Even Orlon, for that matter, is a homopolymer. The only answer is dacron. Okay, because it is made up of 2 different kinds of polymers. So the correct answer, I went on ticking all this. So the last answer in this case is dacron. Okay. So the answer for this question will be dacron. Option number C. Bakelite is made up of phenol and formaldehyde. The initial reaction between the two compounds is, okay, so phenol is this and it reacts with formaldehyde to give you phenol formaldehyde polymer. So what is this reaction? So what is going to happen here? If you know how is this polymer formed? These chains CH2 groups form here. So this is a kind of aromatic electrophilic substitution reaction that is happening. Okay. So bakelite is formed by reaction of phenol and formaldehyde, and the initial reaction that is going to happen here is electrophilic substitution. Okay, so this question has appeared in your CET in 2013. Which of the following is a biodegradable polymer? Polyhydroxybutyrate copolymer hydroxyvalerate. What is the short form for this? PHBV. Right? So option A is your correct answer. Which is the monomer of neoprene in the following? Okay. So what is the formula for neoprene? Neoprene is nothing but this. Okay. What is the name of this? 2-chlorobutadiene. Okay. This polymerizes and gives you neoprene. So in this case, the answer is option A. Okay. 2-chlorobutadiene polymerizes to form neoprene. Which polymer is used in the manufacture of paints and lacquers? Okay. So for the manufacture of paints and lacquers, that is the question. So if you see very carefully, paints and lacquer, bakelite is used for making switches. Okay. Polyvinyl chloride is used for the making of pipes. Okay. What is polypropylene used for? Polypropylene is used for a similar purpose. Okay. So I think, according to me, the answer for this question should be glyptal. Okay. But still, I would just verify and tell you whether this is correct or not. Yes, this is the correct answer. The answer is glyptal. Okay, I just wanted to check whether I have given you the correct knowledge or not, because I don't want to give you all the wrong answer. Okay, so I have checked the answer and glyptal is the correct answer because bakelite is used for making switches, and polypropylene is a polymer that is used, for similar purposes like polyethylene. And polyvinyl chloride is used for making pipes. So the only option which remains is glyptal. So ऐसे तुम options eliminate करके भी solve कर सकते हो. Okay. Which of the following polymer is formed from a monomer that does not show geometric isomerism? I felt that this was an important thing. Now, what is geometric isomerism? Geometric isomerism is shown by compounds that have a carbon-carbon double bond. For example, alkene. Geometric isomerism is nothing but cis-trans isomerism. Okay. So if two large bulky groups are on the same side, the isomer is called as cis. If the two bulky groups are on opposite sides, it is called as trans. Okay. So this group is called as trans. So we have to find out a polymer which does not show geometric isomerism. So if you consider isoprene, isoprene कैसे दिखता है? CH3. Here you have double bond CH2. CH2. Wait, we have CH2. Double bond CH2. Okay. So what is this? This is polyisoprene. इसका polymerization ऐसे होता है. So even this will show geometric isomerism or cis-trans isomerism. Now look at this. Polytetrafluoroethylene. If you look at this carefully, the structure for this is CF2 double bond CF2. Now all these groups are the same, right? So this compound cannot show geometric isomerism. So the correct answer in this case would be polytetrafluoroethylene. Okay. So this question was important important. They might ask you some tricky question like this in your exam also. So this was important. Okay. So I think with that, the questions are over. Thank you so much for listening to this and for giving us your support. Okay. You can definitely call us on these numbers and visit our website. We are also there on social media networking site. Do subscribe to our channel and share this with your friends for their betterment as well. Thank you so much. See you all in the next video. Bye-bye.